Hello. After watching this video, you will know how to turn your mesh topography from this to this, and then this, or this. Now the method that I'm going to show you is mostly for visualization purposes. It has one underlying risk that can have serious consequences if the user of this script does not understand what they are doing. I will go to more detail about this near the end of the video, so make sure to watch this all the way through to avoid a catastrophe. Let's get to examples. Here I have a mesh that I have imported from an ASC file. We are in the rendered view, but you really can't see much detail or get a good grasp of the elevation of the topography. To help us with that, we are going to use a script like this. The mesh is on the mesh layer. I'm using query model objects component to get the mesh. Then I'm deconstructing the vertices and extracting their Z components, which of course means the elevation. Then we have two options. You can use the min-max function to get the minimum and maximum values, or you can get the bounds to create a domain and then remap the domain to go from 0 to 1. The min-max function seems a bit faster if you always know the boundaries for the post-processing, but if you don't, using the remap is a good idea. You will then feed the minimum values to the lower limit input of the gradient component, the maximum values to the upper limit input, and the Z components to the parameter input. If you are remapping the values, then you will use 0 for lower, 1 for upper, and the remapped Z components for the parameter. I will now turn the preview on. Now both of these will provide us with exactly the same result. You can use different gradients to find a representation that you find easy to read. I am using custom gradients from Timo's great video, which I will link in the description. Now in our model, there is a lake here and some hillside here. But many of the gradients are pretty linear, so the shoreline is barely visible. You can of course create non-linear gradients, but if you have varying elevations, customizing them each time would be a lot of work. Now what you can do is that you can use a graph mapper. Here I have created a Bezier curve. If I run the mapped values through this component and feed it as a parameter to the gradient, I can adjust the gradient so at the start the values rise more steeply and it will even off towards the end. I think using this greatly improves the visibility and readability of the topography. If you find some areas where the gradient is too harsh, you can adjust it with the graph mapper. As you see, there are over 1 million values here, so the mesh is quite large and the computation time is rather long, so be prepared for that. You could also do this with the min-max component if you are always going to know the minimum and maximum values of the range of your inputs, because you have to manually edit these values to match those to get a good map. Now for the risks of this method. You are altering the values that go to the gradient component. This is okay if it's done for visualization purposes. But if you are altering the values that come out of a, for example, finite element analysis that you are displaying on the mesh, and someone is using a color bar or something like that to read the results, they can get completely false information because you have altered the results that are being shown. So take caution and understand thoroughly what you are doing before using this script, and if you decide to do so, it will be completely on your responsibility. That is all for now. If you learned something, hit the like button and subscribe to the channel. I will see you in the next video. Thank you for watching.